Algebra I 10.9a, dividing by a monomial. Because rational expressions are fractions and fractions are just little division problems, rational expressions indicate division. To divide a polynomial by a monomial, we divide each term by that monomial. Or we can multiply each term by the reciprocal of the monomial, the divisor. So I know that sounds confusing, so let me show you. Remember, the reciprocal is the upside-down version of the fraction, okay? So the numerator ends up becoming the denominator. We just flip them around, don't we? That's the reciprocal. So if we want to divide this polynomial by this 3, we can either divide each term and do 6x squared divided by 3 plus 3x divided by 3 minus 2 divided by 3, and do each one separately. Or we could take this 3 and its reciprocal is 1/3. That's the flipped upside down version of 3, right? Because 2 over 1 would be 1/2. We multiply each term by the 1/3 reciprocal. And we can solve it that way. So we can either directly divide and split it up, or we can multiply each one by the reciprocal. So let me show you. So here's our equation. We've got 6x squared plus 3x minus 2 divided by 3. We could have also drawn a fraction line and put the 3 below it, couldn't we have? Sort of like I did right here, see? So we're going to multiply each term by the reciprocal of 3, which is 3 over 1. So we're going to flip it around for the reciprocal and get 1/3. We multiply each term by 1/3. We've got 6x squared times 1/3. And we've got 3x times 1/3, and we got -2 times 1/3. And 6x squared times 1 is 6x squared, and the 3 would be multiplied by a 1, wouldn't it? Because 6 over 1 is the same thing as 6x squared. So we'd have 6x squared over 3. For this one, these would all be over 1, wouldn't they? We'd end up with 3x over 3. And for this one, we'd have -2 over 3. Now we can just simplify them. 3 goes into 6x squared 2 times, so it's 2x squared, see? And 3x divided by 3, this 3 cancels out this 3, so all we're left with is x. And we've got a -2/3, so there's our answer, see? Just multiply each term by that reciprocal, all right? So here's dividing each term. So if we have x to the 3rd power plus 10x squared plus 8x, and it's divided by 2x, we can divide each term by this 2x, see? Because the 2 will go evenly into all of them, right? Just remember that quotient rule for exponents. It says if you've got like x to the 5th power over x squared, you do the 5 minus 2, and that would be x to the 3rd, as long as the x isn't a 0, all right? So what we do is we say x to the 3rd power divided by 2x, 10x squared divided by 2x, and 8x divided by 2x. We know there's an invisible 1 here, isn't there, in front of this x, our identity property buddy? So because we've got an x to the 3rd power being divided by this x down here, we're going to do 3 take away 1, because there's a little 1 here, really, isn't there? So now we've got 1x to the 3rd minus 1. That's 1/2. That's just a half x squared. See, 3 minus 1 is 2. So now our exponent is a 2, and we have half x squared. For this one, because there's an x squared here, and this x technically has a little 1, doesn't it? We have 2 minus 1. So that gives us 10 divided by 2, which is 5. And the x squared minus 1 gives us just 1x, doesn't it? And then this one, this x cancels out that x, doesn't it? It's like a 1 minus a 1. So we end up with just a 4. See how I did that? Just remember the quotient rule for exponents, okay? And if it helps you to break each one apart and put the 2x underneath it, then do that. If you can do it this way, then you can do it that way, all right? Doesn't matter. Whichever is easier on your eyes and makes it easier for you to solve, okay? As you get really good at it, you won't need to rewrite it like this. You'll just be able to go like this and do it, okay? Now, there's also another way we can do this, and this is kind of a step up for everybody. This isn't really in the book, but I thought I'd show it to you. We can also first factor out the numerator and reduce the fraction. So if we have a polynomial like 24y squared minus 18y to the third power plus 30y to the fourth power, and yes, this is in exponential order because they're going from least to greatest. We could have written it from greatest to least, couldn't we? And it's being divided by 6y. Well, we're going to go to each one separately, all right? So what we do is we factor out this 6y, and this ends up becoming 6y squared times 4 minus 3y plus 5y squared. See? And if we did distributive property, it would bring us right back to this polynomial. See? Now, this 6 cancels out this 6. This y cancels out one of these y's as a 2 minus 1. See? So now we end up with just a y here, and we can rewrite it as y times 4 minus 3y plus 5y squared. So that's our factored answer, see? And it would be the same thing as if we did 4y minus 3y squared plus 5y to the third. We could have done that just by doing this. 6 goes into 24, 4 times. Y squared, take away 1y is 1y minus, because there's a minus sign here, see? 6 goes into 18, 3 times. Y to the third power minus 1y is y to the second power. And 6 goes into 30 5 times. And y to the fourth power minus 1y leaves us y to the third. See? We just did it as a factored way. See that? So just remember to subtract your quotients because of that quotient rule, okay? Multiplying each term by the reciprocal of the divisor, like we did right here, or dividing each term by the divisor will solve the equation, okay? So you can either multiply each term by the reciprocal of this divisor, flip it around, and just multiply each term and then simplify it, or divide each term and then simplify. See? All right? So our next video, 10.9b, is going to be about dividing by a polynomial. And if you want to see any of the previous videos that we did, we had a lot of word problems for rational equations. Or I'll even put my link to factoring in here if that'll help you out. I have a playlist of factoring videos that you might want to review if you forget how to factor and you want to try it this way. But my advice is to try multiplying by the reciprocal or dividing each of the terms by the divisor, okay? Do it either this way or this way. I just showed you this to give you a step up, okay? But all of those links are going to be in this one's description, okay? And I hope that's going to help you. And I hope you got this. I hope you understood. And I'll see you next video, and we'll talk about dividing by a polynomial. Bye.